These are some problems that we did today in class. I am showing you the problems so that you can try them on your own, and then when you're ready, you can go over the answer. You can see the video to see the answers. So here are problems 1 through 6. Pause the recording, try them on your own, and then here are problems 7 through 12. Again, pause the recording, try these on your own, and then when you're ready to see the answers, you can start the video again. So I'm going to go through each one of these on the board so you get the experience just like you were here in class. All right, number 1, we have barium chloride plus potassium carbonate. Okay, so the first thing you need to do is you need to write your formulas. Barium's in group 2, so it's Ba plus 2. Chloride is in group 7, so it's minus 1. So when you crisscross those, that gives me BaCl2. Potassium's in group 1. Carbonate is a polyatomic ion, CO3 minus 2. So when we crisscross those, we get K2CO3. So those are my reactants. Now we need to figure out our products. To do that, we have to look at what we're given. These are 2 compounds reacting. So what are the products going to be? I mean, what kind of reaction is this? Double displacement, right. So that means that my products are going to be barium carbonate and potassium chloride. Now you probably don't need to write this out every time, but I'm writing it out just to help you with figuring out what your products are, right? Barium is still Ba plus 2. Carbonate is still CO3 minus 2, so this is BaCO3. Potassium is still plus 1. Chloride is still minus 1, so that's KCl. So now we just combine all this together to get our balanced equation, right? Well, we need to balance it. So we have, writing it all on one line, BaCl2 plus K2CO3 produces BaCO3 plus KCl. And now I just ask myself, is this balanced? And the answer is no, it's not balanced, right? So what do I need to do to balance it? I need a 2 in front of KCl. And that's it. Do we agree on this one? Yes. All right. Let's go on to number 2. So if everybody understands that format, do I need to write it out each time? Write out the words? Okay. So I can skip straight to crisscrossing the formulas? All right. So zinc metal. When you see the word metal, you need to immediately think periodic table, right? Metal means no charge. So it's neutral. Just like if you see aluminum metal, think like a sheet of aluminum foil, right? Zinc metal is just straight up Zn, okay? No charge. And aluminum sulfate. Aluminum sulfate. So aluminum is Al plus 3. What's sulfate? SO4 minus 2. Right, so when we crisscross these, we get Al3, Al2. Al2. SO4, 3. Okay, so this is a metal and a compound. So what kind of reaction is this? What kind of reaction? Single displacement, right. So that means that the metal becomes the new cation. Now zinc is in the transition metals. Most of you probably wrote it as zinc 2. Did anyone write it as zinc 1? I would have accepted either one. Okay. So zinc 2 or zinc 1, I would accept either one. So the metal becomes the new cation. Okay, and it's combining with the anion. So that gives me ZnSO4. and the cation becomes the new metal. So what's the formula for aluminum metal? Is it Al plus 3, Al2, Al, what is it? It's just regular old Al, right? Okay, don't put a subscript of 2 here because aluminum is not diatomic, right? It's monatomic. A lot of students will say, oh, there was a subscript of 2 here, so I'm going to put a subscript of 2 here. But aluminum metal is not diatomic, right? There are only 7 elements that are diatomic. So let's clean up our answer here a little bit. Let's get rid of all this. Now we just need to ask ourselves, is this balanced? No, it's not, right? So let's see, we need 3 sulfates. So that means we need a 3 here, and we need 2 aluminums. Do we agree now? Yes. Single displacement. Any questions on number 2? If you made a mistake on number 2, do you see where you made it? Should you ask about what?
It would appear we have like Al plus 3.
So if you wrote this first and this second, is that what you're saying?
On the second part.
So you have this first and this second? Yeah, that's fine. That's fine. Order doesn't matter. As long as the compound formula is correct, doesn't matter if you put this one first or this one first. Yeah, it's a good question. Any other questions on 2? All right, let's do number 3. Number 3, it says burn, okay? So anytime you see burning, you should think combustion. So butane is C4H10. It's being combusted when we say burning, so that means it's a reaction with O2. Now just ask yourself, is this combustion of a hydrocarbon or combustion of a metal? Well, C4H10 is made out of carbon and hydrogen, so that's a hydrocarbon. So what are the products of combustion of a hydrocarbon? CO2 and H2O, right? That's a sad looking tube. Okay, so now we just need to balance it, right? We just got to make our reactant product table. We'll do this one out instead of doing it in our heads. All right, so carbon is 4, hydrogen is 10, oxygen is 2, and then over here, carbon is 1, hydrogen is 2. It's just sad. And oxygen is 2 plus 1, right? Because if the same element is in more than one substance, you have to split them up. So let's balance carbon. So we need a 4, right? Distribute that 4. 4 times 1 is 4. 4 times 2 is 8. Let's balance hydrogen. So we need a 5. 5 times 2 is 10. 5 times 1 is 5. All right, so this sum is 13. Do we agree? Yes. Now, is 13 a multiple of 2? No. There's no way that I can turn a 2 into a 13 using a whole number. So off to the side, I say to myself, okay, 2x is equal to 13, therefore x is equal to 13 halves. So if I put a coefficient of 13 halves here, that turns it into a 13. But are you going to have 13 halves of a molecule? No, just like you're not going to have 13 halves of a pen, right? So how do I get rid of that fraction? Multiply the whole thing by whatever the denominator is, right? So if I multiply everything by 2, 2 times 1 is 2. 2 times 13 halves is 13. 2 times 4 is 8. And 2 times 5 is 10. There's my final answer. Any questions on number 3, combustion of a hydrocarbon? All right, let's go on to number 4 then. Number 4, magnesium metal. So you should just immediately think Mg. Anytime you see the word metal, think periodic table, no charges. Reacts with silver 1 chloride. Silver 1, so that's Ag plus. Chloride, Cl minus, right? So that's just AgCl. Okay, what kind of reaction is this? This is single displacement, right? So the metal becomes my new cation. So when magnesium becomes a cation, it's Mg plus 2. Metal becomes my new cation, and it gets together with the old anion. So when we crisscross those, Mg plus 2, Cl minus, we get MgCl2. And my cation becomes my new metal. So that's just plain old Ag. Do we agree? If you wrote a charge on the Ag, put -1 next to your paper, okay? Because a metal does not have a charge. It is neutral, okay? Now we just need to ask ourselves, is this balanced? The answer is no, right? So you're going to need a coefficient of 2 here, coefficient of 2 there. Clean up our work a little bit. There's the final answer. Do we agree? Questions on number 4? You made a mistake, you see where you made it. Okay, let's move on to number 5. Number 5, calcium fluoride. So that's Ca2 plus and F minus. Yes. So that gives us the formula CaF2 combines with sodium sulfate. Sodium is Na plus, sulfate is SO4 2 minus. So that's Na2SO4. Do we agree? What kind of reaction is this? Double displacement. Right? So that means that the cations and the anions switch. So that means calcium and sulfate are going to get together, and sodium ion and fluoride are going to get together. Right? Doesn't matter which one you write first. So CaSO4 is one product, and NaF is the other. Now we just need to balance it. I'm right on that seam again. Just scoot it down. You need a coefficient of 2. Do we agree? Yes. You made a mistake on number 5. Do you see where you made it? All right, let's move on to number 6. I should probably give myself more room. Calcium sulfate, so Ca2 plus, SO4 2 minus, so that's CaSO4. And ammonium nitrate, so that's NH4 plus, and nitrate is NO3 minus, so that's NH4NO3. What kind of reaction is this? It's double displacement as well, right? So that means calcium and nitrate are going to get together, and sulfate and ammonium are going to get together. So let's do calcium nitrate first. If we crisscross those, we need parentheses, right? CaNO3 2. And then if we crisscross these, we need parentheses again, but this time on the cation, right? NH4 2SO4. Do we agree on the formulas? Yes. This was the one I think you guys were asking about. Now we just need to balance it. It's an easy fix. Which substance needs a coefficient? Right, we just need a coefficient of 2 right there. And cleaning up our work, there's the final answer. Do we agree? Number 6, double displacement. All right, let's go on to number 7. Aluminum metal, so you should automatically think just plain old Al, no charge, reacts with lithium carbonate. Lithium is +1, carbonate is CO3 2 minus, so that would be Li2CO3. What kind of reaction is this? Single displacement. So that means that the metal becomes a cation, so that would be Al +3, and it's combining with carbonate, so CO3 - minus 2. So when I crisscross those, I get Al2CO3, 3. Do we agree? We crisscross, 2 goes here, 3 goes here. And then what happens to the old cation? What does it become? A metal, right, so it would just be plain old Li. And now you need to look at your problem and see if it's balanced. What do we need to do to balance this? You need a 2 here. You need a 3 here. And then what do you need over here? 6 here. Good. Good job. Any questions on 7? Questions? Okay, let's go on then. Number 8. Copper 2 phosphate. So that 2 tells me it's +2. And phosphate is PO4 3 minus. So when I crisscross those, that gives me Cu3 PO4 2. And iron 3 sulfate. So that's Fe3 plus SO4 2 minus. So when I crisscross those, I get Fe2 SO4 3. What kind of reaction? This is double displacement. So copper 2 and sulfate get together, and iron 3 and phosphate get together. So that gives me CuSO4 plus, you crisscross those, that's 1 to 1 as well, FePO4. Yes? Yes. Now we just need to balance. All right, cleaning up our work. So let's see. Let's put a 3 here and a 2 here. If you're having trouble with balancing, there are problems on the website on D2L for balancing equations. There are also suggested problems in the syllabus for each week. So go back to the week we did balancing equations out of the textbook. And then if you want more problems beyond that, I can give you some too. So just email me. I'll be happy to give you more problems on balancing equations. Okay, number 9. Chromium 3 sulfide. So that's Cr3 plus, and sulfide is S2 minus. So that's Cr2S3. Reacts with potassium phosphide. So that's K plus, and that's P3 minus. So that's K3P. All right, so this is also double displacement, right? Another double displacement. So here we go. So that gives me, if I combine these, CRP and K2, that's a 2, S. That's hard to see. I guess I just like the challenge of trying to write on that scene. All right, now we just have to balance. What do you want to make the reactant product table, or can we do this one in our head? If we put a 3 here and a 2 here, and then what else do we need? 2 here. And let's see. 2 potassiums, 6, 2 phosphorus, 6 potassium, 2 chromium. Yep, we're done. Do we agree on this one? Questions on 9? Questions? All right, let's go on to 10. We've got 2 more to go. Oh, excuse me, 3 more to go. 10. Sodium metal and nitrogen gas are formed. So that means they are products. Sodium metal is just plain old Na. And nitrogen gas. Nitrogen as a gas is diatomic, right? that's N2, are formed when sodium nitride would be Na plus N3 minus, so that would be Na3N. So move my arrow down a little bit. 3 there. But does that solve the problem? Nope, we need a 2 here and a 6 here. Do we agree? Do we agree? What kind of reaction is this? The problem says breaks down. So it is decomposition, right? Decomposition. Do we agree on this one? All right. Number 11. Benzene is burned. Benzene is C6H6. It's burned, so that means it's O2. Is benzene a hydrocarbon? Yes. So what does combustion of a hydrocarbon produce? CO2 and H2O. Let's do our reactant product table for this one. So CHO, CHO. So 6, 6, 2, and 1, 2 plus 1, and 2. Okay, so let's balance carbon with a 6. 6 times 1 is 6. 6 times 2 is 12. Let's balance hydrogen with a 3. 3 times 2 is 6. 3 times 1 is 3. Do we agree? Now we've got a sum of 15. 15, is that a multiple of 2? No. So we say to ourselves, all right, 2x equals 15, so x must be 15 halves. So now I've got 15. But do we leave a fraction in an equation like that? No. How do I get rid of it? Multiply by 2. Multiply everybody by 2, right? So 2 times 1 is 2. 2 times 15 halves is 15. 2 times 6 is 12. And 2 times 3 is 6. So my coefficients are 2, 15, 12, 6. Do we agree on this one? Yes. And then lastly, we've got another combustion. The last problem is combustion as well, but it is magnesium metal. So number 12, magnesium metal is burned. Is this a hydrocarbon? No. If you write CO2 and H2O here, I'm going to circle and go, where's the carbon coming from? Where's the hydrogen coming from, right? There's no carbon and hydrogen on the reactant side, so there can't be carbon and hydrogen on the product side. What does combustion of a metal produce? The metal oxide, right? So magnesium oxide. So Mg plus 2 and O minus 2, right? So that's just MgO. So then you need a 2 and a 2. You could call that combustion. You could also call it synthesis. I would have accepted synthesis if you wrote synthesis there as well, because it's multiple reactants and one product. So I would accept either one. Questions on number 12? How do we feel about reactions? Feeling pretty good? All right, that's where we're going to stop.